All right, let's talk about something that sounds like it's straight out of science fiction. Imagine beaming the internet anywhere on Earth using just light. Well, that's exactly what a team at Google's Moonshot factory has been working on. And this little thing, the Taara chip, is the key. It all comes down to this one really powerful question. What if we could get internet at the speed of light without having to lay a single physical cable? For most of us, that's a wild thought. But for the Taara team, it's been a very real mission for years.
So why do we even need a crazy moonshot idea like this? Well, it's because right now our entire digital world is slamming into a massive wall. We call it the bandwidth bottleneck.
Okay, so what is a bandwidth bottleneck really? The simplest way to think about it is like a highway. We keep adding more and more cars. That's our 4K streaming, our AI, our constant video calls, but the highway itself isn't getting any bigger. You end up with a massive traffic jam. That's what's happening to the internet. We've all felt it. You know, the dreaded buffering circle. The pipes are just getting too full. And it's really a perfect storm of problems. First, our global hunger for data is just exploding. It's insatiable. At the same time, laying new fiber optic cables, the gold standard, is incredibly slow and super expensive. And what about 5G? Well, the radio frequencies it relies on are getting more and more crowded every single day.
But a problem this huge is exactly the kind of thing that gets the folks at the Moonshot factory excited. Their solution wasn't to build bigger pipes. Nope, it was to take a radical leap of light.
For 7 years, the Taara team has been absolutely laser-focused on this one mission, to use beams of light to create internet that's not just super fast, but also abundant and, this is the key, actually affordable. So how did they do it? The really huge breakthrough came when they rethought the whole system, moving away from big, clunky mirrors and towards something much more elegant, tiny microchips.
Just look at the difference here, it's incredible. The first-generation system, the Taara Lightbridge, used actual moving mechanical mirrors to aim a beam of light. It was the size of a traffic light. Now, this new Taara chip does the exact same thing, but it's all done with software on a solid-state chip that's the size of your fingernail. No moving parts. That is an absolutely mind-bending leap in technology.
The magic behind this tiny chip is a technology called an optical phased array. Now that sounds complicated, but it's basically the brain of the operation. It's a system that uses software, not physical parts, to steer, track, and correct that beam of light with unbelievable accuracy. So how does it steer light if nothing's actually moving? It's genius. The chip is packed with hundreds of tiny light emitters. Software then acts like a conductor, controlling the precise timing of when each one flashes. By manipulating these timings, it can literally shape the wave of light and direct the beam exactly where it needs to go, all with code. Okay, that's the how, but let's get to the good stuff. What can this thing actually do? The performance numbers are where this technology really starts to look like it can break past the limits of traditional fiber. Let's start with speed. The top transmission speed is a blistering 20 gigabits per second. To put that in perspective, that's right up there with high-end fiber optic internet. And the range? A single link between two of these little things can span up to 20 kilometers. That's over 12 miles. Insane! And this isn't just theory. In real-world outdoor tests, they successfully blasted data at 10 gigabits per second over a full kilometer. Yeah, this tech is ready for prime time. This is where you see the practical magic. It's already been deployed in places where laying cable would be a nightmare. Like beaming internet across the Congo River, a new link can be set up in a matter of hours, not the months or years it takes for fiber. And because it's using light, it completely avoids that crowded radio spectrum we talked about. But as amazing as the current stats are, they're just the beginning. The long-term vision here is about creating something much bigger, a future of abundance. So what does that future look like? Well, imagine a global mesh network made of these tiny chips. You could bring true high-speed internet to remote villages for the very first time. You could totally revolutionize how giant data centers are built. Or think about autonomous vehicles. They could communicate with each other instantly, making them incredibly safe and reliable. It's a game changer. You know, the team behind Taara said it best themselves. The possibilities are as boundless as light itself. That quote really captures the sheer scale of what they're aiming for here.
And this future isn't that far off. The next generation of Taara, powered by this very chip, is scheduled to launch in 2026. And the team is already putting out the call to researchers and innovators everywhere to start dreaming about what we can build with this new tool.
And really, with this kind of power becoming accessible, the real question isn't just what they'll build. The question is, what will we build with the speed of light?